In section 7.3, you will be looking at systems of linear equations in two variables. Systems of equations consist of two linear equations and sometimes more. We will only work with two linear equations. The solution is an ordered pair which occurs where the two lines intersect. So the solution for this particular system of equations would be the point 1, 5, because that's where the two graphs intersect. So when you write your solution for these systems, you will write them as an ordered pair, x, y. There are different possible solutions that you could have. You could have one solution. That means the two lines will intersect at exactly one point. So you'll have one solution, which would be an ordered pair, x, y. Or you could have infinitely many solutions. That means the two lines are really the same. They overlap one another. So the equations are the same, especially when you reduce them or manipulate them, they end up being the same. For the last possibility, you could have zero solutions because the two lines are parallel. That means they never intersect. So you would have no solution. So let's determine whether 2, -3 is a solution of the system. Negative x plus 3y equals -3. Negative 5x minus y equals 2. So in place of x in the first equation, you're going to substitute 2. And in place of y, we're going to put -3 because based upon the order pair, this is x and this is y. So when we substitute that in, we check it in both equations. The first equation, we have -2. We substitute the 2 in, so it becomes -2 plus 3 times the -3 equals -3. We want to see if this is true. When we evaluate this, we get -2 minus 9 on the left side, which is -11. And we know that -11 is not equal to -3. We do the same for the second equation, -5x minus y equals 2. In place of x, we put 2. In place of y, we put -3. We get -10 minus 9 because 3 times -3 is -9 is equal to 2. When we add these together, we get -19 is equal to 2, and we know that that is not true. So 2, -3 is not a solution to this system of equations. Alright, there are different methods that we can use to solve systems of equation. One of them is the elimination method, and that will be prominently used in this particular course. So let's consider this system of equations. 3x plus 3y equals 3 and 4x minus 3y equals 4. What we want to do is eliminate one of the variables. Quickly, we can see that if we add these two equations together, the y would be eliminated. So let's do that. Let's add the y's together. Let's add each of the columns together. So we're going to do 3x plus 4x, that's 7x. Positive 3y minus 3y, that goes to 0. And 3 plus 4 is 7. So now we have 7x is equal to 7. And we divide both sides by 7, and we get x is equal to 1. Alright, now that we know x is 1, we can substitute in either one of the original equations. It doesn't matter which one. In place of x, we're going to put 1 in one of the original equations. Again, it doesn't matter which one you choose. So let's substitute in equation 1. In place of x, I'm putting 1, so I get 3 plus 3y is equal to 3. Then I subtract 3 from both sides, and I get 3y is equal to 0. And then I divide both sides by 3, and I get y is equal to 0. So I know x is 1, and I now know that my y is 0. So the solution to this system is 1, 0. We'll be looking at applications of our systems of equations, and one of those applications is cost and revenue. Revenue is the money generated by selling X units of a product. So you make money from selling the product. That function is R of X is equal to the price per unit sold times X. The price per unit sold times X. The cost is the cost of producing X units of the product. All right. Usually there's a fixed cost that you have to come up with, plus the cost per unit produced times X. So these are the two functions that you will be using, revenue and costs. For example, well, not example, but break-even point. The break-even point is when revenue is equal to the cost. That's when you break even. You don't make a profit. You don't lose any money. You just break even. Revenue is equal to costs. We have what's called the profit function, and profit comes when you make some money. So profit is generated after producing and selling X units of a product. That is determined by revenue minus costs. So if you have some money after you subtract the cost of making a product, then you made a profit. So revenue minus costs is equal to profit. Revenue minus costs is equal to profit. For example, the formulas show the cost function C of X is equal to 3600 minus 36, and that should be plus 36x. See, can I get that? Oh, I can't. Plus 36x. Again, that should be a plus. And the revenue function R of X is equal to 48x for a company that manufactures and sells small radios. How many radios must be produced and sold for the company to break even? How many radios must be produced and sold for the company to break even? All right, so we talked about break even. Break even is the point where you make no profit but you lose no money. So revenue is going to be equal to cost. So on our graph, this graph represents the revenue. The dark line represents the revenue. The lighter line represents the cost. We break even when they both are equal to one another, right here. We break even when they both are equal to one another. Revenue equals cost. So, to calculate that, we're going to set costs equal to revenue. Well, we know that cost is 3600 plus 36x, and we know that revenue is 48x. So we set them equal to one another and we solve for x. First thing I chose to do is subtract 36x from both sides, and I got 3600 is equal to 12x. Then I divided both sides by 12 and I got that x is equal to 300. So that means the company must produce and sell 300 radios to break even. 300 radios to break even. All right, the profit function. Remember, the profit occurs when revenue exceeds costs. So the profit function is P of X is equal to R of X minus C of X. So for this particular problem, the same problem we just finished working, if we use those same functions, we know profit is R of X minus C of X. And in this particular problem that we just finished looking at, the revenue is 48x minus, and you want to make sure you put this inside parentheses. This is very, very important. Make sure you put this C of X inside of the parentheses, so that when you distribute the negative across the parentheses, notice how the sign is changed, and this becomes 48x minus 3600 minus 36x. Very, very important. Collect your like terms and you'll get 12x minus 3600 is equal to the profit function. Alright, now that we know the profit function, we can figure out what the profit would be if we sell 1,000 radios. Oh wow, so many mistakes in here. Sorry, I do apologize for that. That should be 500 radios. In place of the 1,000, instead of, you can try 1,000, but also let's look at 500. So if you sold 500 radios, then in place of your X in the profit function, you're going to put 500. So you'll have 12 times 500 minus 3,600. You get 6,000 minus 3,600, and you now know that your profit would be $2,400. So if the company sells 500 radios, they will have a profit of $2,400. Try that for 1,000 radios and see what the profit would be.